This was going to be a postbag item, but as there's only one, it's turned into a postbag stroke teardown. So I hope you enjoy it. So, as all good people do, we rip our way into it. And what's inside? Another box. Now this is a very light, empty battery. Well, pretends to be a battery. It has a lead that plugs in the top, and then an unknown block to USB. So I'm assuming that 5 volts goes in here on the USB into here, and this boost converts it to the 7.5 volts that the Canon camera that is up there needs. Whether I'm going to use it like this, I don't know. I don't want to risk an expensive camera on a cheap bit of poop on here. So all I was toying with the idea was to run it off a bigger battery. So, you know, I was going to look for something like that. That's too big. Also looks a bit puffy. I've never used this battery yet. Yeah, it's puffed up. That's a bad battery. So that might get dismantled and see what it's puffed up. But you know, something that sort of size, so I can run the camera for a longer period of time. Right, here it is on the bench in all its glory. Don't need that bit. I'm not going to take that apart. It looks like it's welded, and it's basically going to be connected from here to the battery terminals. So there's no point in taking that apart. So we'll have a look at this. Looks like I can get into it. Yep. Prise it open. Oops, my fingers. Right, out it comes. What do we have? Bring that camera in. Right, here we have it. We have, so we can see what the chip is. The light on it just right. Maybe we can get FP6293 is the chip. 27E down there. 6R8, not sure what that is. Well, it's an inductor, but not sure what the value is. SS34, 2 diodes in parallel. And a 10D and a 10C resistor down there, and a shoddily put on capacitor on the output for some reason, as it's already got two 220 volt capacitors on it. But what I'm concerned about is if I bring in trusty meter, let's move the microscope out of the way, that we need that at the moment. If we power it up, we get 8 volts. Now it's a lithium ion battery that says 7.2 volts on it, so I think I might reduce the voltage on the output, maybe down to 7.5 or something like that. I don't, maybe 8's a bit high, but I'm not sure if I'm going to use it anyway, as you know, it looks a bit shoddy, and all I want to do is power what which to me is an expensive camera, and I don't want to risk something going wrong on here and this 8 volts shooting up to 12 or something and breaking the camera. But I basically bought it for that bit and the plug, so I was expecting to waste that anyway. But so we have a closer look at the circuit. Alright, here we have the data sheet. to show that the FP293 is a current mode boost DC-DC converter, and it has a 0.14 ohm power MOSFET, and has a very strange low 0.6 volt position reference voltage when you look at a lot of them around 1.25. We can see here its features. It's adjustable up to 12 volts. It runs at 1 meg. It's got a 2% error on its position reference. It has a low current shutdown, over for temperature protection, and can go up to 3.5 amps. Wide range of applications. This particular board has got it in this configuration using this 8-pin chip, and it's basically wired up exactly like this, apart from it has two Schottky diodes here, and it has 2 electrolytics and 1 ceramic. I'm not sure if there's a capacitor on the feedback. Move on down. I can't quite get that to fit in. We got a function block diagram, and we can see here's the feedback, and it uses the error amplifier to determine uses a PWM signal which drives the MOSFET. And the strange thing is there's a current sense amplifier here, but the current limit is adjustable up here via the control and driver logic. Now why they've done that and why they haven't just brought that pin out so that you could put your own value there, I don't know. They seem to think that's the way to do it, so who knows. It also has a soft start, so it doesn't draw much current on startup. Don't really want to look at the pinouts. Maximum rating 6 volts. So nice temperature range, -40 to +85. That used to be mill standard almost. I'll leave a link in the description, and some more of the data sheet. There's no point reading this, you can all look at it. It's got a soft start circuitry built in to slowly ramp it up. There's a current limit programmer pin. I shall have to have a look at the value of that resistor to calculate what the value is set for. Over temperature protection, not sure I'll ever get to that. And maybe I could cut the EN pin and fit a circuit so that if it goes above 7.5 volts it shuts it down, but will it be fast enough? I don't know. So I'm not sure if I'm going to plug a couple of quid circuit board onto a several £100 camera. They recommend a 3.3 to 4.7 microhenry, and the board looks like it's got a 6.8, so they didn't go with a recommendation. A bit on the capacitor selection and diode selection, and the typical R1/R2 +1 for the voltage settings. We'll go in and look at what those resistors are at some point. And again, the typical application, very, very close to it. They've virtually copied, apart from they've only got one capacitor on the input, they've virtually copied this. I expect I'll probably find that resistor is 100k. So feel free to download the datasheet and have a look, and I'll just glance over the rest. Well, that's about it. Let's go back and have a look at the board. So we'll have a quick look. Using my trusty scalpel as a pointer. Pin 2 was that current limit, 27E, so we'll have to measure that to find out what it is. Pin 6 goes off up here to the 2 resistors that set the voltage. We have the inductor, we have 2 Schottky diodes in parallel, the 2 output capacitors, and that hideous little one stuffed down there. So basically I need to find out what is a 10D and a 10C, and also a 27E. It looks like there could have been a component there. It's not, I think, fitted, and there's nothing on the other side apart from it says input DC 3 volts to 6, max output 8 watts, output DC 5 volts to 12 volts. Reassuring that you're going to plug this into a camera worth a lot of money, and it says 5 volts to 12 volts. That's about it. So let's find out more about what value these resistors are. Right, I've got the values now. It wasn't 27E, it was 27K. So we'll work out the current limit in a minute. The potential divider for the output was 10D, which was 124K, and 01C, which is 10K. Right, if you look up there, you'll see that there are 2 resistors and a space for a second one. When we look over there, and there is the formula for working it out. So currently we have V out equals 0.6 times 1 plus R1, which is 124K over 10K, and that gives us 0.61 plus 12.4, which again gives us 0.6 times 13.4, which then equals up or adds up to 13.4 times 0.6, 8.04 volts, which is what we measured. So I was thinking I'd like to have it down to say 7.5. So then we want 7.5 divided by 0.6 equals 1 plus x over 10k, which then is equal to 7.5 divided 0.6, 12.5, am I doing this right, is equal to 1 plus x over 10k. So then that's equal to 13.5 is equal to x over, oh that's minus, isn't it? It's minus, so it's 12, it's 11.5 equals x over 10k, therefore x equals 115k. So we have effectively that. So there's our 10k, that's the feedback, that's the output, that's the 124k. So if I'm working backwards now, if I want to find that x there, I could go 1 over 115k minus 1 over 124k, and then 1 over the answer, and that will give us Rx. So if I calculate that out, I'll let me show you. Can you see it on there? 115 exponent 3 x minus 1 minus 124 exponent 3 x minus 1 equals that. 1 over the answer. Rx equals 1.584 mega ohms. So I'm going to go away, I'm going to see if I can find one of them, and we'll stick it in and see how it goes. But before that, pull up that, which is the current limit on the board. Current limit, we have 48000 and we have 27 under there. So the current limit on our board I won't bother to do this. 48000 divided by 27000, 1.78 amps is what the current limit should be set to. Right, so I'm going to go and find a resistor and modify the board. Turn my soldering iron on. Let's bring that over here. Will we be able to see that? It's going to pull them out of the way. And tweezers, where's my tweezers? So I need to fit. I think this one might be the slightly different size, but it might fit. I'm lucky. Should I do this on camera or not? It's going to be a bit finicky. Some solder. Problem with this, I like doing this with my microscope. and I haven't got it out. Oops, I'm burning the wire, so probably wasn't a good idea. Anything for a bit of fun. Can we actually see what I'm doing? I bring that up bigger. It might help me solder. No, this resistor is too big, isn't it? That, well, it seems to be holding on. What's the worst thing it can do? It can go bang. So I've no real plans on using this to power my expensive camera. I just bought it because it was a cheaper way of buying the battery holder. I'll move that up because of the see how I melted that lead. I'll my leads tiled up. Problem with these silicon leads, they are super flexy, you know, but they do love to tangle. They're amazingly good at tangling up and tying knots in themselves. Right. Put that in there. Hey, look, 7.5 volts. So the calculations worked. So if I can find a resistor that's small enough, or 115, oh, I could find a 115k resistor and take off the 124, put that in. Or I could find a smaller 1.5 meg resistor. But that's knocked half a volt off the output and brings it, I don't know, in my mind, closer to a 7.2 volt. Well, if you like this video, please click on the subscribe button, click on the like button, and click on the bell for notifications of any videos I release in the future. Bye for now.